In this video, we will talk about history of distributed systems. This video is very important because we are going to see the whole history from monolithic SOA microservices and today's serverless computing, right? So, monolithic has lot of drawbacks, but SOA microservices and serverless are very important concepts even for your career, or if you are looking for placement, you can learn these things and get job easily. Right. So, it is very important you understand. If you understand about microservices, serverless and SOA well, then you understood the whole unit 2, that is SOA and service sign. Right. So, first one is monolithic architectural style. We already talked about client server. In client server, what is happening? There is one server. In this server, we are installing the software, installing the required software. Then we are writing code. Let us say you are installing Java and then writing code using some IDE, right? Then you are testing it here itself and you are deploying it, right? Deploying in the same server, in that machine only you are deploying it, right? So, this is server, and we will have client. Client are low configuration machines, okay? So, they will be sending request and getting response. If you see the server alone, see, I am writing code, right? When we are writing code in this style, that is in client server style, right? So, we used to write the code as a single program, okay? Single program, single large program. Earlier, when people were designing software, they were learning software programming, they were writing programs, building small applications, they used to write only a single program. Even in lab, if you see, you go in any programming lab or any other lab, if you are writing ML lab, you talk about, your tendency is to write a single program for a given problem. Because it is a small program, you are writing a single program. So, earlier people used to write a single large program, a single program which will do all the operations, and that single program they will convert into the maybe .archive and then deploy this into the server, right. So, I think in Java we have lot of extensions, right. You will have .java files, this .java you convert into archive, something like this you convert, and you convert into jar file, sorry, you convert into .jar file, and this jar file we generally deploy it. Okay, so they used to write a single program, they used to write a single large program for everything. Now, let us take example about banking. Let us say this is server belongs to banking application. So, you will be writing here, you will be having here one program. In that program, you will be talking about withdraw, you will be talking about deposit, you will talk about pin change, you will talk about balance inquiry, you will talk about checks. So, all these were written as a functions. In C++ or Java, if you see, in one class you can create lot of functions, lot of methods you can create. So, in a single program they used to have all these functions in that, and the program will be single Java, that is main.java, main.java. Only one program used to be there, and that is to be deployed in the server, right. Mono means single, mono here, mono means single. Monolithic means writing a single program for building a whole application. Any application you do, see, earlier we did not have front ends, we did not have app, mobile app, web apps, we did not have laptops at all, we do not have browsers. So, we used to write only kind of what we say Linux programming, C++ programming, only C programming we used to build applications. Okay. So, they used to write a single program. This is okay, this is monolithic style. When you are building an application, you will be writing it as a single program, and that single program will contain everything. Let us talk about banking example. Since I said there are a lot of functions like balance inquiry, withdraw, right. So, let us say that that program is 10,000 lines. The whole program is some 10,000 lines. It has database connectivity, it will go to the database, it will connect to database, update your money when you are withdrawing it, right. When you are checking balance, it will show query and show you the amount. So, the full program is in 10,000 lines. Now, you developer 1 wrote this program. After few years, a new developer comes into place, and there is one line in that whole 10,000 lines, there is somewhere we are giving 5% interest to to candidates who are saving their money. Okay, now the new government has come. They told no, increase the interest rate to customers to 6%. Increase it to 6%. So in that whole program of 10,000 lines, at some places there is 5%. You have to go check it and make it 6%. It is not as easy that you simply do Control F, wherever there is 5 put 6. That may not go wrong. Some cases we have to give 5% only, some cases we have to give 6%. And this 5% might be belonging to gold loan or any other aspect. So blindly you cannot change number 5 to 6. Why? Because you have to understand that code. So the new developer who is coming, he has to read the whole code, understand it, then find out the actual place where interest calculation is happening. There he has to make this change. That is point number 1. After making the change, he cannot simply blindly deploy the code. Why? Because program was working fine. By making a small change 5 to 6%, so many other things get impacted. We do not know. Right? So rigorous testing has to be done. Then they have to deploy it. And since we are saying about client server, in server, if I have to do this much changes, there will be a lot of downtime. Because application is down, you are making some changes. So the downtime will be very high. Why downtime will be very high? The new developer has to open this 10,000 lines, understand it completely, change that to 6%, test the whole application again, and then deploy it. So it might take 1 day also sometimes. Right? The downtime can be very, very high. Okay, so that is the challenge in monolithic style. Even to make a small 0 to 1 or 1 to 0, you have to test the whole program, because you do not know, because of that change, is there any impact anywhere else. So you have to do testing properly. So maintenance is a challenge in monolithic style. Why maintenance is a challenge? Maintenance means change requirements. Right? Maintenance means change requirements. You are making a change from 5 to 6%. So you have to maintain that code. Means you have to open it, change it, test it and deploy it again. Right? Maintenance is challenging. Why? Developer has to understand everything. Some bad programmer writes a program 10,000 lines, it will be very difficult for you to read. You do not know what is that variable X, Y, Z, ABC. He might have used lot of variables. So which variable is for what purpose, we do not know. That's why it will be very hectic and challenging for a developer to make changes in the existing code. That is point number 1. Second point, if there is any error in the program, let's say in that 10,000 lines, there is some error in that, and you do not know why that error is coming. You have to debug the whole code. If some error is coming in the program because of some mistake you have done in database connection or somewhere, you do not know where is the error coming. From the logs, you have to trace back, you have to go to the code, understand it completely and find out the root cause and solve it. Again, test it properly and deploy. So even for a small error in the program, your downtime is again high. You have to it's challenging also. You have to understand the whole code, identify the bug, fix it, test it again and deploy it. Right? So that's why we say single point of failure. No, since in the program there is some failure, nothing can work. Maintenance is high. Maintenance downtime is very high. Right? So all these are drawbacks in the monolithic style. Okay, and another aspect, you wrote the program in C++. Now that Windows operating system or Linux operating system is not supporting this version of C++. What you have to do? Again, you have to change your version. So you have to upgrade your system. Sometimes Windows does not support Windows 8, 7, no. So we have to update it to Windows latest versions. So for that reason, your system, your server where this code is written or deployed is also in older version. So you have to again upgrade it. It's also challenging. Why? When upgrading, let's say C++ is completely removed. Now it is existing, but I am just giving an example. You have to change your whole code to Java. Then you have to do lot of work. It is full headache to convert this 10,000 lines to Java program. Like this, there are so many drawbacks in monolithic style. Okay, and where are we deploying it? Where are we deploying the code? We are deploying it in a single machine. We are deploying in a single machine, single server, I will say. Okay, we are deploying in a single server. Means I wrote the code in this laptop. okay, in this machine, and I am deploying it here only. It is in your office, in the bank, branch, wherever. So, since you are deploying in a single machine, if this machine fails, program gone, your application gone. Short circuit happened, application gone. Hard disk crashed, motherboard some problem, full, all problems will come with this monolithic style, right. So, these are few challenges in monolithic style. This was the only style earlier, but slowly people started facing problems in this monolithic style, right. So, before the internet era, or when the internet was just growing, people were using only monolithic style, okay. So, to overcome these drawbacks in monolithic, right, they came up with a new solution around 2004-5, right. This new style was proposed, service oriented architecture. What is this SOA? So, in monolithic you are having a single code, 10,000 lines. In this, all withdraw, deposit, pin change, balance inquiry, everything is written here only, right. So, what SOA is telling, when SOA came into picture, they said that you break down this monolithic large file into business oriented services. The new term service came into existence. Service means anything which is doing some task, okay, taking some input, and service is just a program, you say, okay. Business oriented means business or functionality oriented, means functionality wise you separate the program, means you make separate. See, here there was only one program, P1, now you make services, S1 withdraw related everything into this service, S2 all balance inquiry related, S3 all pin change related, S4 all deposit related, S5 all interest related, S6 all maybe check related. Like this, they told to divide the services, divide this whole program into small pieces based on the functionality. So, all withdraw related code is here, all deposit related is in S4. Now, the new manager comes, or the new person, new bank system, government introduces new policy for banking, they say make change in interest calculation. Like earlier, they told no 5 to 6%. This time you see, all these are services, separate Java programs. This is separate Java, this is separate Java, they are deployed separately. So, when we have to make a change 5 to 6%, unlike monolithic, here I have to touch only this program. I have to touch only S5. Only S5 I have to read. So, what happened, that 10,000 lines, this became 2K lines. Each one became 2,000 lines, let's say roughly. Okay, 2K lines, this became 2K line. Now, instead of searching or understanding the whole program 10,000 lines, you are just working on 2,000 lines or even less. Maybe interest calculation will have only 1,000 lines, let's say. So, your job, your time to understand the code has been reduced. You can easily understand this 1K line and make the change here. You need not worry about any other services, and you need to test only this. You need not worry about other services. Only the interest calculation service alone you have to make changes. That alone you have to test it. So, the downtime is less, and the application is available. See, when interest calculation you are making some changes, right, withdraw can work, balance inquiry can work, pin change can work, deposit can work. Only this will not be available. All other functionality will be working properly. So, in web application, when you see some web application portals, websites, right, some module will not be working. In NITT, you have admin here, academics here, center, something are there, NIT Trichy website, right. So, this part alone, it will be down, remaining 3 will be working fine. You can access the website, you can do whatever transactions or business you do with the website, right. That is the advantage. Business is not going down. We are having downtime is only for interest calculation, not for the other functionalities. Your bank can still work. Why? This program is separate. So, maintenance downtime is very low, making changes is very easy, it is not headache in SOA, right. But the style what they proposed during that time, the deployment was still in a single machine. Still in a single machine. Though I am deploying as separate Java files, right, This alone I have to stop, S5, and remaining all will be working fine. But we were deploying in a single machine. So very rare cases, if server is crashed, full application gone. So all drawbacks of that single machine problems will appear here also, right? But other problems are solved here, right? Other problems like maintenance downtime, understanding the whole 10,000 code, somebody wrote the program and left, you are given the task to read it and understand, that all problems are gone. It is very easy for you to understand 1000 lines and make the change. It is less risky compared to monolithic, right? This is what they have said. Okay, but what happened to this SOA? And along with SOA, something came is web services. These services, no, this withdraw, balance inquiry, pin change, web service means something which is exposed over internet. Exposed over internet. Like weather application, you see, wherever you go, you just click the weather, it will, there is a central weather server is there. From that it is fetching you and giving the temperature to you. So there is a web service which is deployed, which is giving us the weather of this particular location continuously. So our server is hitting that particular web service and getting the response back. Okay, so web service is just another product of SOA. Same thing, the same service which you are writing here, that functionality based service, that you are deploying it in the internet, making it available for public. Anybody can access this web service, this service through internet. Okay, I think most of the applications what you see today, calculator, age calculator or other conversions you see, no, all those are web services only. Okay, so web services was the most popular implementation of SOA, right? So again, anyhow we will understand web services more when we study about web services in second or third session, right? So what happened with SOA? Why this also failed? What happened is, see, you see now, earlier we did not have UPI, we did not have UPI, we did not have credit card, we did not have debit card when banking was started. Slowly government introduced, or the banking people introduced debit card. Now what happened? This totals you see 2000, 2000, 2000, 2000, 1000 and 2000 lines is there, right? Now when they got the debit card, they had to, what happened? It is related to withdraw, no? So this withdraw function 2k became 5k now. It became 5k lines. Why? We have added new features related to withdraw, debit card. Okay, we have added debit card, withdraw using debit card facility. So that withdraw function which was 2k lines became 5k lines. Then we got credit card. So it got impacted in everything. It got impacted in, again this 5k became 10k lines. Then we got UPI. So new services were added UPI. UPI has relation with the withdraw and deposit because we are transferring money, right? So this code became, because of UPI, this 2k became 5k, right? This became 10k, like this, because of day by day change requirements. See, they got internet banking, right? Internet banking came into picture, mobile banking came into picture. Day by day banking system has added so many features. So the individual services which we earlier had, each one was of 2k lines, roughly we thought, right? These 2k lines, because of those change requirements, today they became 10k lines. After 10 years or 12 years or maybe 5-6 years, it became 10k lines. Why? Best example, in Facebook you see, when I was using Facebook, only there was upload picture option, nothing else. Later they bought like, later they bought comment, slowly they bought reply to comment, then they bought like the comment, then emojis came into picture, then emojis for comments also, then you can tag somebody else, you can tag the location. Like this, day by day in Facebook it has grown like anything. So the application code has increased in size because of change requirements, continuous improvements in the application. The SOA services, which we have divided them into small pieces, right, became 10k lines. When it is 10k line means what it is? It is also monolithic now. All these services in SOA became monolithic. See, earlier we spoke here, we had one program of 10,000 lines. This was challenging that time, but today after few years, that SOA, which was very easy and simple initial days, because of so many continuous change requirements, each service became 10,000 lines. When it became 10,000 lines, again all the challenges of monolithic came here. Right? It is difficult. Even in withdraw function, if I want to make a change, it is difficult because 10,000 lines again. Finding where to make the change, test the whole application, withdraw function will be down. All that drawbacks of monolithic came to SOA also after 10 years. 2005 SOA was popular. After 2000, by 2013, 14, 15, people started realizing lot of drawbacks in SOA. SOA was tending towards failure. But I should tell you, SOA is one of the most popular software architectural style, because when the internet was growing, see, during 2000s only, somewhere around 2000, 2003, 4, no, 5, internet was growing. When internet was growing, people started doing business. They started converting their business into online business because internet is there. They started building software applications. So during that time, industry people saw what is the latest style of designing application? SOA. So everybody, your Amazon, Flipkart, your banking, SBI Bank, IRCTC railway ticket booking system, Passport Seva, right? All the major applications. Okay, everybody have used SOA. You can read more about this internet. People, this has been very, very successful style. Even with web services, it became very, very popular. Because during that time, when the industry was growing, people were starting building their business applications, internet was growing, this was the only available style. So everybody blindly followed SOA. Your Airtel used this, Vodafone used this, Jio used this, right? I think I remember these things because Tata Docomo was their network. Everybody have used SOA style only for designing applications in those days. So initial attempt was only in SOA by everybody. That's why this is still today some 5% projects are still running on SOA, because that much popular it was, right? So this is about SOA. So why SOA failed? Because we are deploying in a single machine. We are deploying it in a single machine. That is one deployment in single machine. Second one, all SOA became monolithic. All SOA became monolithic in nature. That's why it has failed. Okay. Then after 2015, they started to find out a new solution for that. Right? What is this new solution? They decided that no, let's go with. They proposed a new style called microservices. Now, what is it, microservices? See, those small services in SOA, which were 10K lines, right? They told break them further into small services. So many small services. Like this. Okay, the condition was that every service should do only one task. It follows single responsibility principle. Microservices follow single responsibility principle. Means this service should do only one task. So the 10,000 lines of withdraw, it was converted into almost 100 plus microservices. It was connected to 100, I am just giving a rough number, 100 plus microservices. Now you see, I want to change interest to 5 to 6%, it is changed only in one service, which is hardly from 50 to 150 or 200 lines. Less than that actually, 50 to 100 lines only, max. In this I have to make a change. Even the services of withdraw are working fine, except this one. Remaining all the functionality of withdraw are working. UPI is working, bank ATM card, debit card is working, everything is working, even in withdraw. Only one service I am changing, which contains very small code. So it is very, very easy to make a change in the microservices. It is very easy to make change. Why? Downtime is very, very low. I have to test only this one, and remaining all can be working fine. So, one program became some 10 in SOA, it became 1000 in microservices. That many number of microservices have increased. Now you want to add a new feature. Let's say UPI Lite has come, or withdraw money from ATM using UPI has come. So banking people need not touch the existing. They have to add a new service. That's it. They have to add few more small services. That's it. Okay, you need not worry about the existing 1000 services. You need not touch them. There is no scope of adding code. The only option for you available is creating new microservices. So creating new microservices, I need not worry about the existing functionality. The application can be working fine, running fine happily, right? So that is about microservices. You want to make change, you can take only one small service. Within minutes you can make change, test it and deploy it. Okay, downtime is very low. You want to add new functionality, add new microservices. That's it. So business is not impacted here. And the major point here to discuss is that we are deploying them. They said that when you are deploying microservices, deploy them in the cloud, not in physical single server. Okay, so when you are deploying microservices, they strictly said that each microservice should do one task only and it should be deployed in the cloud. Why cloud? Other two drawbacks you see, monolithic and SOA. If you observe, if server is failing, complete service gone, because we are deploying them in a single machine. That too in physical server at my location, on premise we say, on campus server, whatever it is there we are deploying. But putting in cloud, you know the benefit of cloud, auto scalable. Right? So you need not worry about the scalability issue in the microservices. Why? Because they are auto scalable. That is one advantage for you, and cloud can never go down. You need not worry about physical server, its RAM, its hard disk capacity, its CPU clusters, whether it is slow, fast, running up or down, no worries at all. So in both the styles, what is that, in monolithic and SOA, we are deploying them in a physical server. That has been removed in microservices. We have to deploy them in the cloud strictly. Because of this, even microservice can be deployed in local server, it will work fine. But they are proposing the standard, what they are telling is deploy them in the cloud. So there will not be any issue about scalability, load balancing, server failure, server crash, all that problems are gone. Okay, another advantage of microservice is that in a monolithic, since it's a single program, right, we are forced to write in a single programming language. In SOA, when we are having services, right, though we are breaking down into services, since they are communicating with each other, we were again forced to write in a single programming language, either Java services or C++ services or Python services, like that, right? But microservices follows, it says it has one feature called polyglot. Polyglot means you can write each one service in one language. There are 1000 microservices, 100 could be in Java, 100 could be in C++, 100 could be in Linux, 100 could be in .NET, Go programming language, in Python language, any language you can write. They can communicate with each other. Okay, so that is one major benefit in microservices. But the whole idea I just want to say, we have to break down the SOA into smaller services. So making changes is very easy. Adding new changes, it is same as adding new services. So less headache, right? So this way microservices is very trending. It is the only, and there is nothing beyond microservices now. We feel this is the end point in software development. So after 2030, this is my prediction, there will not be any Java developer, front-end developer, everybody will be a microservice developer. You will be developing, you will be writing only microservices, nothing else. Okay, 90% of the IT applications will be completely based on microservices style, right? So this is the history about monolithic, then SOA, and then microservices. Till here it has stopped. This is about designing applications, right? This is about designing applications, how you write your code. That's what we have seen, how from monolithic to microservices, how we are going. So this is trending and happening now. Everybody, today's Amazon website, shopping website, what you are seeing, it is based on microservices. And there are 23,000 plus microservices in the Amazon website. This is a valid, true data. I know people working in Amazon, right? 23,000 plus microservices are there. Okay, lot of other facts of microservices I will discuss in our fourth session of this unit, right? This is fine, happy, but I also included in one more concept called serverless computing. What is this serverless computing? See, in all three, monolithic or SOA or microservices, what you are doing in your laptop, you are installing the software, you are writing code, you are testing it, then you may deploy it in the cloud. Let's talk about my latest microservices, deploy in cloud. This you are doing, right? Installing, writing code, testing, everything you are doing in the your laptop only or your office given system, whatever, right? Suppose you are working on some licensed premium software that will be installed only in your machine. So, if you are in different state, different country, there is some error in your program, can you work on that? You have to come to office only, open that machine only and do changes there only, nowhere else you can do, because that code is written in your laptop and the licensed software is installed in your machine only. You cannot make the change, you have to be there in the office. This machine is lost, can you build the application? No. Again you have to purchase a new laptop with the same configuration, install that same licensed software and then only you can write the code. So this is a problem, right? So there is a lot of dependency on the physical laptop or the machine, right? So post COVID, during COVID what happened? Everybody was working in desktop machine, like in our lab. They were going to office, in that desktop machine they were working. Suddenly lockdown is there, they were sitting at home. Now I have to do the work at home. How do I work? Laptop is, machine is there, software is installed there, code is there, right? So people, those who are laptop they bought home, they were working okay, but what about others who were working on the systems? So post COVID, a new style has emerged and it is trending like anything, that is serverless computing. What is this serverless computing? It means in the cloud platform, you log into the cloud platform, same writing code, you need not install anything, writing code, testing, deploying, everything you can do in the cloud itself. You need just any machine with internet. You have your credentials, you have your username passwords of AWS, Azure or GCP, you will log into that and you will start writing your code, you will test it there and deploy there. Wherever you are in the world, if you have anybody's laptop, you take, connect to internet, log into the AWS or Azure, make changes and deploy. Programming from anywhere, right? Building or working for your company from anywhere in the world. That is what is possible with this serverless computing. Okay, so this serverless computing we'll discuss in the unit 5 when we talk about emerging trends in cloud computing, that is serverless computing. Okay, so in lab what you are actually doing is serverless programming only, serverless computing only, but when you talk about Lambda, AWS Lambda, or Azure functions, right? These two are the serverless services in cloud platforms. Okay, so we will understand more about this. I think this is one of our lab experiments as well, right? Exploring AWS Lambda and Azure functions. Whichever language you want, whichever version you want, you can write it wherever you are in the world. You can log in, choose that particular version of the software, write program, test it, deploy it. Right? That is serverless. See, serverless means server is not there for you. You are not managing anything in your laptop. You are not installing anything. You are not doing any configuration setting. You are not worried about RAM or anything. That's why it is serverless for the developer. Serverless for the developer. But actually servers exist, maintained by the cloud provider. So cloud provider is taking care of the server management. For you as a developer, you are not managing anything. Just log in into the website, do programming. right? All your data structures, array, C programming, Java programming, any programming you can do in cloud itself. You need not install anything on local machine. That is about serverless computing, right? So this is just a small added point in this pipeline. So the current trend is that you have to write microservices, you have to follow microservices style, principles of microservices style, deploy them. So microservices you are writing as serverless functions. So you are following the principles of microservices and doing that programming in the serverless platform. That is the current trend now, right? So microservices doing it in serverless platform. Okay, so this is what that's why if you see here I just kept no, this is no in parallel, so both are existing equally, right? I hope you understood the history of distributed systems, right? Thank you.